And therefore LM is a vector subspace. Okay? Now
Yes,
this
sir.
is true for each M in reals. What is important is, so this tells us since the dimension of R2 is 2, we know that we can have, since the dimension of R2 is 2, we can have subspaces if you have a subspace. Then its dimension can be 0, 1 or 2. Okay? There is only one subspace of dimension 0, which is the zero space. Okay?
Yes, sir.
There is only one subspace of dimension 2, which is R2. Then you have several subspaces as you change your M. So here is another one. Okay? For a different value of M. So as you change your values of M, you get different subspaces. These are each subspaces of dimension 1. But this one, the y-axis is not captured here, so that comes up in this one. Okay? So this is your y-axis. So you have, so this is actually all the subspaces of R2. It is this, the 0, R2, all one-dimensional ones, which is this and this.
So, sir?
Yes?
If we had x, like the coordinate system would be to be x squared, right? We'd have an x squared graph, but x squared is enclosed under vector addition. No, it doesn't have a vector inverse. So
wait, slowly. So if we had this subspace, a subset, okay? If we had this subset, obviously 0, 0 belongs to this, but let's look into a scalar multiple. Let's look into 2 and 2 times x squared. This is 2x and 2x squared. And this doesn't belong to L, because this one is not, this one, this y second coordinate, this is not unless x is 0. So this set is not closed under scalar multiples. Hence,
But then, sir, then how is P in a vector space?
How is?
P in a vector space, the thingies of all polynomials, the set of all polynomials.
Good, but that's the addition and scalar multiplication. You say Pn, I write it like this. Okay?
Yes, sir.
So this is firstly, how is this a vector space? Okay? What are its? Firstly, the addition is different. If I have Px and if I have Qx, then Px plus lambda times Qx, this is sorry. So this is again a polynomial of degree at most n. So this is a vector space, vector subspace of Rx. But your question is pertinent, and it is because your question is this x and the x over here are not the same. Here, although I'm using the same letter x, here x is a real number. Okay? Here x is a real number, and I am over there also x is a real number, but there is a little bit of a difference. The difference is here. This p is actually a function. Its value at x so it's the set over here, under consideration. So Rx is a set of functions the operation is given on the set of functions. That means I am adding two functions. I am scalar multiplying a function by another function. Okay? So the operation is on this set. Whereas over here, L also represents a function. This is the function This is also representing a function, but what we are trying to say, So what is L? L is actually the graph of L, F. Okay? So if you actually try to draw this, your L looks something like this. Okay? This is your L. If you draw this. What I'm interested is whether L is a subspace of R2 or not. So here the question is whether L is a subspace.
But so aren't all subspaces vector spaces?
One minute, I've not finished. Here, here it is actually a little bit different. Here you are actually, if you look upon this, you are also having graphs. So, over here, if you take px, suppose who is this? Please close your microphone. Suppose your px is x squared and qx is x cubed. Okay? Then here is the graph of px. The graph of x cube looks something like this. Okay? And which center is this? Can you please close your microphone? Whereas, say for instance, if I look into Px plus Qx where lambda is 1, your graph looks something like this. Okay? So that's another cubic polynomial. That's another cubic polynomial which looks something like this. Okay? So, still wrong. 1 minute. It will still be above. So it will look something like this. So that's the graph of, so you see, I'm trying to say a completely different thing over here. I'm not saying whether a particular graph is a subspace of R2 or not. Here my vector space itself is completely different. Its elements are these individual graphs that I've drawn with blue, red and green. Okay? And I'm saying if you add them, it is still there. So it produces another graph.
Yeah.
So you see the question is completely different. Here the vector space is the vector space of functions. Here the vector space is R2 and we are interested whether one particular graph is a subspace or not. Remember, this graph